Hello and welcome back to the V-LiSEMOD database walkthrough. If this is your first video, or if you are watching the series, welcome. Today I'm going to show you how to use our landing page. For example, if you come to the landing page of our tool, you will be faced with this very question. Now, if you've seen the video on the Ligand indexer, you understand what that tool does. If you have also seen the video of what querying based on proteins do, wonderful. If you haven't, and this is your first video, I highly encourage you to also check those out after you've seen this video and learned what we can do. So I'm going to show you this tool right here. And so in this case, we have various viruses already pre-curated. You have HIV, and you have all of the PDB codes with ligands associated with various proteins from HIV. If you already know your ligand ID, or if you already know, in this case, your PDB ID, your 4-letter code, you can go ahead and type that in, and it will allow you to make the next selection. And so in this case, you see we have DR7, and depending on if various PDB files contain other ligands, this is where you'd be able to differentiate them. And if you are interested in information on the binding pocket, this is representing all atoms from the proteins that were within 5 angstroms of an atom in the ligand. Selecting this option creates an object containing all of the atoms in the binding pocket as a yellow surface. If you are interested in the solvent-exposed atoms detected using the Shrake-Ruppli algorithm, you would select this option. This involves a probe with a radius of about 1.4 angstroms, and it's used to generate an equidistant mesh outline of the complex's surface. Selecting this option will color these atoms from the ligand that are solvent exposed. And this is important for various types of chemistry. In the case of the chemistry I do, this is important for detecting potential sites for linkages. And so this is nice. You'd be able to see the types of linker sites and then work with chemists who can potentially help figure out how to work with these solvent exposed regions. And then last, functional group atoms. And these are part of larger functional groups. Selecting this option generates a PyMol session that already selects the objects for each of the functional groups, allowing the user to visualize them however they prefer. And this is nice for when you're working with chemists that want to look at entire functional groups in their space to see just how much modifications they can make. Now, the last thing we're going to do is we're going to generate our PyMol session. So we select this option right here, and what our database does is it creates a .pml file in our downloads. And so you can see in our downloads, we have our 3EKY file that we just created and the .pml. And so we can go ahead and open this with PyMol. And what this will allow us to go ahead and also do is once that PyMol file opens up, we will be able to visualize what this compound looks like in space. We can also generate ligand images, which I will show you afterwards. And so depending on how you obtained PyMol, you will have a license, or if you don't, you can skip activation. And all it does is when you go to actually open up some of the files, or if you go to save some of the images, you will end up getting a watermark. But I personally prefer PyMol but some people use Chimera, which is just as fine. I don't know if Chimera can read a PyMol session. If it can, cool. But remember what I had mentioned before, the binding pocket and the solvent exposed atoms. And then these over here are the various functional groups that were identified in this molecule. But for now, we're just going to look at the binding pocket that's created. And so what we're able to see here is we're able to visualize the atoms from the receptor that are part of the amino acids that bind to our small molecule. We can then identify which atoms are potentially solvent exposed. As you can see here, we have quite a few solvent exposed atoms, so there's a lot of sites for potential linkage. That's very good when you're developing PROTACs. Additionally, I had mentioned that we have a generate ligand images button. And so what you're able to do is it loads in the information that you gave it. So we wanted to look at 3EKY and the ligand DR7. So this is another way we can look at those solvent exposed atoms. Now in 2 dimensions, you can see those same solvent exposed atoms, but in an easier to visualize manner. Remember the 2 sides that we saw that the pocket had? Here you can see which atoms were actually part of those pockets. This is nice if you're a chemist. This is nice if you are looking at functional group modifications. And then if you're interested in seeing the molecule in 3D directly on our database, directly on our tool, without having to download the PyMol file, here it is. Unfortunately, it doesn't contain all of the same information, as in it doesn't have the solvent exposed atoms highlighted for you here. It doesn't show you the actual binding pocket, but it does give you a nice visualization. And then if you are interested in downloading the images for the DR7, or if you want the solvent exposed, and then the last thing that this page currently does is it can actually show you the ligand interaction diagram. Currently, it actually interacts with another database, another tool. And what it's able to do is it is able to actually generate these nice ligand interaction diagrams where you're able to see in 2 dimensions which ligands are binding with which residues, or which residues and their respective functional groups are binding with which portions of the small molecule. Right here we highlight where what the interaction diagram can show. It highlights hydrogen bonds. It can show pi interactions, hydrophobic contacts, and all of this information can quickly be downloaded. So that's another reason why you should want to go ahead and use our tool and our database. And so that is the home page's functionality. I highly suggest checking out the ligand indexer or figuring out why it's important to query based on proteins. Thank you and have a wonderful day.